talk to other disciplines about stuff. Okay, so I think I'm going to start. Welcome, everyone. Hopefully we're all in the right place. A lot of you have been here a few minutes, so I appreciate it. This is the info session for computer science technology. But I figure if you found this weird little room in the building, you're in the room. So first off, I'd like to welcome you to Open House. On behalf of the computer science faculty, we're happy to have you here at Dawson College. The comp sci faculty is actually pretty big. We're about 15 full-time teachers working in the department. My name is Dirk Dubois. I've been teaching in the faculty for about 4 years. My colleague Carlton is with us today, and Miles. We've both been teaching with the department for a long time, and we're here to help answer your questions after the presentation, should you have them. Something I want to highlight about our wonderful department is that almost all of our faculty have relevant industry experience that we leverage to help prepare students for the real world. So I think a good place to start is, well, what we learn as part of the program. Well, the objective is to be able to create state-of-the-art software systems, right? Using various programming languages and operating systems, how can we bring all those tools together to ultimately work and collaborate as part of a team? So as a 3-year technical program, we really aim to prepare students for the work world. So there's an emphasis on state-of-the-art technology being used today in industry and learning how to work as a team collaboratively together. So a bit about how the program is structured and how we meet that objective. So we have our programming stream where students take 6+ courses in programming languages, concepts like Java and C#, where they work in both individual and team projects. So usually in the first year, everything's about individual projects usually, so that students can build a base, they have some knowledge they can draw on, and then from that point on, we do teamwork. This is all about getting people ready for the real world, learning how they can work together, communicate effectively, work on large-scale projects. Then we have our web stream, where we've got about 5 courses that cover everything from HTML and CSS to JavaScript, lots of modern web technologies, so that at the end our students really are what we call full-stack web developers. They're able to build products from A to Z that they can deliver to customers. Of course, it's important to also capture where is all this stuff going to run, right? We are maybe making some really cool websites or some cool products. Where is it going to live? So we have an infrastructure stream where we have courses that look at computer hardware, operating systems, deployment, making sure that you can take all those cool things you've made and actually ship it to you, the users, so that people can actually consume it and use it in some way. And so we talk a lot about building and connecting systems, right? How you bring all these different pieces together to make it all work in concert. Of course, we need some sort of underpinning behind that to save data, and so databases is part of our program as well. We have 2 courses on that looks at structuring data and analyzing information, where we can talk about the fundamentals and design of how you bring that together. And of course, these all work together to help students build large-scale projects. And of course, finally, there's the professional aspect, right? It's a 3-year program. You're meant to go to the work world. So we have courses that cover things like professional skills, preparing for our internship course, so interviews, CV building, all that sort of thing. That finally ends in an industrial internship or stage. So as part of our program, students get an opportunity to go and actually put all their learning into practice in industry. So where will the program lead you? Well, you can become a software developer, a web developer, a quality assurance tester, and these are just some of the things our students are able to do, right? We're preparing them for real-world jobs, and these are some of the titles you may have heard that you can do at the end of the program. So of course, because we're practically oriented, right, we've got this internship in the final semester, so the program really prepares students to work for the world. And then in the very last semester in the winter, we have a 7-week internship that students participate in, where they're placed with an employer of some kind and end up working in the field. And the idea is to bootstrap them into understanding what the work world looks like, have some connections with some employers, kind of understand what the real world looks like. And so that's what we offer as part of the 3rd year that allows students to get those employments. Of course, we've worked with a lot of companies over the years for internships, companies like Morgan Stanley, TS Imagine, National Bank. We're always looking for new companies to work with. So if you happen to be in tech and you're interested, some computer science interns, come up and talk to us. We're always looking for new partners to place our students. Of course, there's no assumption that you have any previous knowledge. We teach everything from the ground up. So we provide all the scaffolding and knowledge for students to be able to succeed in the field of computer science. We don't expect you to come in already having taken classes in something, for example. We provide all the facilities to be able to work with that, computer labs, the software needed in order to succeed and do the program. Something unique to Dawson College's computer science technology is our laptop loan program. So if you can't afford the equipment that you need in order to do the program, the college will provide it for you free of charge. So for your 3 years you're here, you want a laptop, no problem, you're a CST student, we'll loan you one for the 3 years. You gotta give it back at the end, but for the 3 years we provide it for you, no problem. We also, in the computer science courses, don't use any textbooks. We make sure that all material is freely available for students, so it's as easy to access and equitable as possible. We really want students to thrive. Of course, I want to highlight that faculty are coming here with lots of industry experience. I used to work at Matrox Imaging. We have faculty who used to work at Mozilla, Shopify, Microsoft, Ubisoft, all these big name companies, big and small, and they bring all that experience to bear as we design our projects, as we instruct our students. We also have societies to help students build a community. They're going to be doing 3 years, right? They get to know their peers. We want them to feel like they're included and part of it. So one of those societies is the Dawson Ada Society. It's a space for CS students who identify as women, non-binary, or other gender minorities. They do a lot of activities and workshops to help build community, to make sure that everyone feels together and not alone as part of the program. And that's one of the societies we have here to help make sure students feel like they're part of our community. Okay, now the technical jargon. Understanding I'm faculty, not the registrar's office, but what do you need to get in? Well, you need a DES, a Diplôme d'Éducation Secondaire, or an academic background judged equivalent to the DES. And you need a secondary for math, the technical and science option, or any of the other higher maths is, of course, accepted as well. And that's our only admission requirement, as far as I know. A little bit about our admissions. So the program in the fall admits about 120 students. Last year we had about 600 applicants. And the lowest high school average overall last year that was accepted was 78%, just to give you a sense of what those numbers are. Now you may be worried, wow, that sounds really competitive. We are certainly not the most competitive program at Dawson College. That would be the crazy science programs. But we are somewhat competitive. I have to go over this these days. As you may have heard, there's a Law 14, formerly known as Bill 96, which impacts our registration model. So the new language law impacts the admissions process. Students are now separated into 2 categories, certificate holders and non-certificate holders. You may have heard of the COE. By law, the college must provide RA to COE holders under Law 14. What's a COE holder? A COE holder is students who had the option to study in English at the primary or secondary level. That usually meant that your parents also studied in English in Quebec. So that's a COE holder, and everyone else is the non-COE holder. So admissions wanted me to communicate that Dawson College, for the computer science program, offers admissions to certificate holders, i.e. Anglophones who went to English school, with a minimum average of 75% before any non-certificate holders, until 70% of the program is full. And they can adjust those numbers, depending. Again, I'm not the registrar. That said, you may look at this and go, well, I'm a non-certificate holder, am I going to get in? Today, our program is still about 50-50. This rule is working well. We don't want the ratios to change. We want everyone to have the opportunity to come to Dawson. And currently, the numbers have remained about balanced. So about 50% of our students are non-certificate holders, just so that you're aware. Again, I'm not the registrar. I thought it would be cool to look at some demos of the student work and what they produce throughout the program. I think what's really cool about this is that at the end of the program, you have something really concrete that you've made that you get to point to and say, hey, look, this is something that I've created. So one of these is this flocking algorithm. This was an individual student project that they coded. It's emulating this behavior of birds clustering together to avoid a prey. This student skinned it with aliens and this little spaceship here. They did everything from the graphics to the interactions, the algorithms behind it that made this possible. This was a last year project done in their final year, and this was an individual project a student put together. This was another group project that was done as part of our web courses, where they did CO2 emissions and natural disasters visualization. So they have this interactive map. This was a website that people could click around and interact with, and it provided all this data that you could sort through and filter, and it had tables where you could put in numbers and see how it behaved. And what's neat about this is that it's a real website that they deployed that people could go and interact with, right? So this is a real product students made that you can interact with. You can change the way the data is shown. I believe in a minute they click somewhere where they show you like the total number of disasters, the emissions grouped by country. And so students built this thing from A to Z. And so this is what students are capable of doing in their last year. This is a cool paint drop simulation. This was another final year project. You can imagine it's like a bowl of water, and you're dropping down drops of differently colored ink. And they programmed all the behavior to show the way the paint would interact with each other. So you can see they've got all the selections to change colors and that sort of thing, but also that the paint distorts and moves on screen as you put more paint down. I think they do a pattern in a minute, so you can see the drops moving and distorting. So they figured out all the math for that, the implementation of it, the coding of it. They did this cool pattern generation, right? So they really make concrete things that they get to take with them at the end. This was a capstone project done in the 6th semester. It's another website. It was this keyboard typing competition site. So the objective is to type the phrase as quickly and accurately as possible. What was neat about this is in the 6th semester, we sort of do like a mock job for the students. So they developed this product with a faculty member who plays the role of customer, and they learn what a real development process looks like as if you were in industry right before they go on their internship to help prepare them for the work world. And they build something like this as part of that. So to summarize, what will you learn? Well, we're going to create state-of-the-art software systems. Where will the program lead you? Any of those job titles and more. I think our students are very versatile. There's no previous knowledge required. We provide everything to help you succeed. And we admit about 120 students every fall to the Computer Science and Technology program. Does anyone have any questions? Yes? No? Yes, please.
In terms of graduates, what's the percentage of people
yes.
go to higher
So,
education versus work?
Okay, so how many go to higher education versus go to work, or how many graduate in total? Or, I'll answer both, why not?
Higher education versus work.
Yeah, so about 50%. So first off, if you complete this degree, you can absolutely go to university. That's not a problem. It depends on the year. Some cohorts it's very high, it's like 50, 60%. Some years it's lower, it's like 40%. But I would say that about half on average, about half the students opt to continue on to university. They don't need to, but they choose to do so. And the degree does not bar you from doing that. So you can absolutely go on to university. That's not a problem. You get a deck degree, you can totally go to university, not a problem. In terms of how many people graduate, we've actually really had a lot of success recently in terms of ensuring students complete the program. So we started about 120, and in the last 2 years, our graduating cohort has been somewhere around 64 to 68. Now, some years it shrinks, some years we go down more closer to like 48, 50, but we've had quite good success recently in getting students from A to Z in the program. Did that answer your question? Great. Other questions? Yeah, please.
What kind of marks are necessary to get into the program?
Like I said, last year the lowest high school average accepted was about 78%. Again, I'm not the registrar office. They would be able to give you a better answer because we're faculty. For me, it's a bit of a black box. People apply, they turn a crank, and then 120 students appear, and I see them in the fall. I'm not super involved in the registrar, but that's the numbers I have.
It really depends on how many applicants you get.
Yeah.
Is there a lot of competition for the program?
There is, well, I can tell you I only know how many applicants we get. So last year we had 600 applicants. So that's still quite a lot compared to the 120 spots we have. But I would say it's not the most competitive program at Dawson College. The sciences are super, super competitive. we're not as competitive as that. Yes?
I want to know what type of jobs does
Sure.
someone finishing this program and what are they called?
Yeah, so some of the jobs that they might get would be titles like a software developer or a web developer or a quality assurance tester. We have people who end up working in like the networking space as, you know, I guess in networks. Tech is like, we don't have a lot of standard job descriptions, but those are some of the titles that they might have. Yes?
Do you guys take into account the rise of AI when preparing the students? Because a lot of the jobs that you mentioned are a little bit at risk given the rise of AI.
Yeah, that's a great question. So the answer is yes. So we're tackling, I mean, we can't be blind to AI. AI is here and it's certainly impacting the market. We see it. So we have a twofold approach. One is how do we adjust our pedagogy to deal with AI, right? Especially when we need students to still learn those fundamental skills from the ground up, right? So we've taken steps to adjust the way our assessments are done to make sure that students are still learning things effectively. That said, AI as a tool in the industry is certainly also prevalent. So in our last year, we're looking at how AI is folded into our courses as a tool that students learn. So I'm teaching the capstone project in the winter semester, for example, and we're looking at what AI tools we're going to show the students, how we're going to integrate it in the learning environment, in the activities we're teaching, so they can learn how to use it alongside all their other skills to become effective developers. So it's absolutely being integrated into the program live now. Great question. Other questions? No, it was super, super clear. That's great. Anything else? I'm happy to answer any other questions. Yes, please.
With this technology program, let's say people who want to go to university, can they use that as a prerequisite for computer science?
Absolutely. So the deck totally allows you to go on to university. The thing that you may need to be careful about is the prerequisites that you need for a particular program. So if the program you're applying to, for example, needs calculus, well, students don't take calculus in our program. Most of the students who go on to university kind of know that that's the trajectory they want, and they take calculus here, say at night or during the summer. You can totally do that. It's actually not a problem. A lot of students do it. But the other advantage is, depending on the university you go to and the program you apply to, you may get cross credits. So for example, if you go into computer science at Concordia, they give you a lot of credits from courses you've already taken at Dawson that like takes off almost a full year of classes off your degree. So maybe you have to make up some prereqs at university, like say calculus, but they've taken off all these computer science classes that you've already done. So it's sort of a trade-off. But yeah, you can totally use this degree and go to university. It's not a problem. Yes, please.
Do you know how the high school average is calculated?
I have no idea how the high school average is calculated, but I'll tell you who to ask. So the registrar office is the people to ask. They have an info booth that they're running in 4F1, which is right down the hall here, and I would definitely go ask them. My understanding, Miles was saying earlier, that they definitely look at your math grade as well as your overall average when they're looking at the admission, but exactly how, I'm not privy to, but they'll be able to tell.
Thank you.
Yeah, no problem. Any other questions we can answer?
Yeah, I have a question.
Please.
What's the difference in this degree compared to the university degree?
Compared to a computer science like degree at university?
Yeah, that's it.
Yeah, they're fairly different. One is that firstly, this degree is very practical, right? You see all those demos of all those projects people built, right? We certainly focus on how to use tools in a practical way to solve real-world problems, right? So our students come out very equipped and comfortable with environments and tools and building things in an industrial way. How do I work in a team? If you study computer science at the university level, it's certainly more theoretical, depending which university you go to, because everyone's got their spin. But it'll certainly be more theoretical. There's less of an emphasis on teaching tools and more an emphasis on it's your problem, learn it. And there's certainly less of an emphasis on teamwork. We make a big effort for people to be in teams from year 2 in every course and learn how to work together. That's something that you might see in an engineering degree, but not so much in a computer science degree at the university level. That answer your question? Great. Well, if you have any other questions, feel free to come up to either myself or Miles or Carlton here. We're happy to answer your individual questions. Thank you so much.